Solving today is problem 1. It reads, 0.750 liquid aqueous solution contains 90 grams of ethanol, C2H5OH. Calculate the molar concentration of solution in moles times liters to the negative 1. Okay, before we start, I want to explain something to you. Moles times liters to the negative 1 to moles times 1 over liters, which is equal to moles over liters. So to prove this, we'll say that moles equals 6 and liters equal 3. So we'll put it into our calculator. Moles times 3 to the negative 1 power gives you 2. Moles times 1 over 3 gives you 2. And moles over 3 gives you 2. This is mathematical proof that these three formulas equal the same thing, which is molarity, which is basically just the relationship of moles divided by liters. So that's something that you might want to take into the future. So no matter which one of these equations you see on your question, you know that they are just asking for molarity, which is basically just moles divided by liters. Alright, so back to the original question. Okay, so the first thing we do is state what we're looking for. F equals what we're finding. N equals the concentration of the solution. Now that we have what we're looking for, we can state our given. We were given 0.750 liters of an aqueous solution and 90 grams of ethanol, C2H5OH. Alright. They want us to find the concentration of the solution in moles times liters to the negative 1. So as of right now, we have our liters. Check. But what we're missing is our moles, because they only gave us grams, which means that this isn't the only information that we need to solve this problem. So what we need now is to find the molecular weight of ethanol so that we'll be able to convert our 90 grams into moles so that we can ultimately solve this problem. Okay, so to find the molecular weight, you merely state the atoms you're working with and put down their atomic weight. The atomic weight of carbon is 12, the atomic weight of hydrogen is 1, and the atomic weight of oxygen is 16. And you'd multiply that by the number of atoms in the formula. So in this case, there are 2 carbon, 6 hydrogen, and 1 oxygen. This equals 24, this equals 6, this equals 16, to ultimately equal 46 grams per moles. Alright, we have our molecular weight. So we can obviously solve our problem now, right? Wrong. This is not the same as moles. This is just a ratio. This is saying that for every 46 grams, you have 1 mole. Alright? So when you get this far in your problem, when you're working it for your homework or for your test, don't get confused just because you see moles here. This does not equal this. Okay, so now I'll show you how to get from this to this. Okay, so we'll start out with our simplest known amount, which would be 90 grams of ethanol. And then we go on to our next ratio, which will take us from grams to moles, like we want. So the only real ratio that we have is the 46 grams per mole. So we'll use that. We need to be sure to check our units when we put down our ratios, making sure that the ratios are inverse, meaning that grams in this case grams should be on the top and grams should be on the bottom in the second part, with our desired unit at the top, usually. There are exceptions, but we're not going to go into that. Okay. C2H5OH, C2H5OH. Okay, so these two cancel out, and we are just left with moles, which is what we want. So what we'll do now is enter it into our calculator. So this works for Casios. I'm not exactly sure about other models. I don't actually work with other models. I prefer Casios. But we would put in 90 over 46. I personally like to put it into the fraction, and as a fraction, because it mimics the way that it looks in the actual paperwork that you do, and I just feel like it makes it a little easier, but it's whatever you want to do. So we get 1.96 moles. The reason I say 1.96 is because I just rounded the second digit after the decimal. But if we were doing this as significant figures, the least amount of significant figures that we have would be 2. So really, we could round to the first place after the decimal. Because there's a 5 after the 9, when you round up, you'll round up to the nearest, you'll round to the nearest even number, which in this case would be 0. Leaving you, in this case would be 0, and because so basically you end up with 2. But I prefer to work with this one, so I'm going to work with this one. Alright, so now that we have our moles equals 1.96 and liters equals 0.750. We just have to use the equation given, which was moles times liter to the -1. So 1.96 times 0.750 to the -1. Let's plug this into our calculator. We get 196 times 0.750 to the -1. which gives us 261.3 molarity. Okay. Alright, so this is also a quick example, because I meant to do it, on checking your calculator. Now, what I have written down is 1.9 moles, but what I put into my calculator was a 196. It can mean the difference between having the correct answer and the wrong answer every time. Decimal places matter. Don't forget that. Alright, so the correct answer, now that we have checked our decimal places, is 2.61 molarity. Okay. Now, you can check this so we know that molarity equals moles over liters. Okay, so we merely plug in our 2.61 molarity, and we can just leave one of these blank. I choose personally to leave the moles blank, so we'll leave that as N and fill in the liters, 0.750, and we would just multiply it by 0.750 and cancel that out, and to equal N 2.61 times 0.750 equals 1.957, which rounds to 1.96. N equals moles, and that is exactly the amount of moles that we had to work with initially. So this answer right here is correct, or is correct. Okay, and that is how you solve for the concentration of a solution in moles times liters to the -1, and also how you check it. Thanks for watching.